what you do is you pick those inputs where the lowest isocost touches an isoquant, or saying the same thing where the isoquant is tangent to the isocost line, right? So what the second point here says is the following, right? The isoquant is tangent to the isocost line. That means they have the same slope. So this means the marginal rate of technical substitution is equal to wage over the rental rate of capital. The marginal rate of technical substitution, if you remember, is the marginal product of labor over the marginal product of capital. And if we do this switcheroo here again, where I switch these ones over, I get the marginal product of labor over wage is equal to the marginal product of capital over the rental rate of capital. Right? So what I've done here is I've gone from the second statement where I say there's a tangency, marginal rate of technical substitution is equal to the input prices. I've written that out explicitly now, recognizing that that marginal rate of technical substitution is just the ratio of marginal products. That's equal to the input price ratio. And then I'm just switching those around by dividing both sides by W and multiplying both sides by MPK. And what I get is this amazing formulation here, where the marginal product of labor divided by wage is equal to the marginal product of capital divided by its rental rate. Or in other words, where you're at the cost minimizing point where the last dollar spent on capital gives you the same additional output as if you were to spend that same last dollar on capital. Did I say capital twice? I did, didn't I? Let's try again. So you're minimizing costs where the last dollar spent on labor will get you the same additional output as that same dollar spent on capital. Right? That's got to be the optimal. If that weren't true, if you would get more additional output out of a dollar spent on labor versus capital, you should hire more labor. If the converse were true, you should hire more capital. So there's three different ways of characterizing the optimum here. All three are true, and all three will get you full credit on the next midterm. All right? So that's that. But Max, you sort of pulled a fast one on me here. All right? So you just all of a sudden started minimizing costs, right? I don't like that. I like having a fixed budget constraint and trying to get on the highest possible indifference curve. I finally trained myself to think that way. Was that wasted effort? No, it wasn't at all. You can think of cost minimization and output maximization as the same thing. So if you like getting on the highest indifference curve, subject to a budget constraint better, that way of thinking, you can think of it that way in production as well. So if we draw again, I forget where our $160, so that was 13, well, let's do 13 and 13 here. Stop mumbling to yourself, Max. Bad teaching, bad teaching. Okay, so let's draw an isocost curve. So this here is an isocost of $160. So what you want is you want to get the most output you possibly can, given that you only get to spend $160. All right? So I can draw an isocost here. Let me just see where I have to land so I don't hopelessly confuse you. Between 5 and 6 and 6 and 7. Okay. Get on a higher isoquant. Not terrible. Okay. So this here is Q equals 80. I'm making up these numbers. Q equals 90. Q equals 100. So what's the highest isoquant you can get on that still shares a point with your $160 isocost line? It's this one right here. L star. K star. And if this is the same firm I drew earlier, it doesn't matter whether you get on the lowest isocost curve to produce $100, or take that same lowest isocost curve and get on the highest isoquant you can possibly produce. You will end up with the same L star and K star. You can approach it from both sides, and you will get the same answer given the same technology and wages and rental rates of capital. All right? There we go. I've got two more things I want to do, then I'll give you back your exam. Now, Max, you don't want your exam back? You should get it back. You did well. Okay. Factor price changes. What on earth are factors? Well, factors, pay attention in Karras' class, all right? Factors are factors of production, labor, and capital. So factor price changes happen all the time, right? The cost of capital changes, wages change all the time. So what happens to our changes what happens to our optimal input combination if all of a sudden factor prices change? Either labor becomes less costly or capital becomes less costly, either way. So start with a, how do we do this best? Start with a steep budget constraint, steep isocost line. Ooh, Max, budget constraint. It's an isocost line, all right? We'll start with a relatively steep isocost line, which here suggests that capital is relatively inexpensive and labor is really expensive. Think of, IT. Computers are cheap, brains are expensive. That's what you're all betting on, okay? So at this initial input price combination, this firm produces 100 units of output and uses, this combination of inputs, K star, L star. Right? It's the same thing I drew earlier, only now that the input prices are much more skewed towards high cost of labor, low cost of capital. And, well, capital is cheap, labor is expensive. What you're seeing here is a relatively high capital to labor ratio, much more capital than labor. Now what happens? Computer programmers go on sale, all right? Wages change. So if this here, this isocost is, I don't know, $200. If you wanted to produce 100 units, you would pick the isocost curve that's tangent to your isoquant right here, but that has the new slope of the new lower wages, okay? So wages drop. And now what are you doing? Well, you're using much more labor, and you're using much more capital, much less capital. More labor, less capital. So what happened here, right? We had a really steep isocost line because labor was really expensive. Now wages dropped drastically for computer programmers, and the thing rotated, right? The slope changed. Remember, the slope of the isocost curve is wage over rental rate of capital. If wages drop, the thing becomes flatter, and you can now produce 100 units with an optimal input combination that's much more labor intensive and much less capital intensive. Now here comes the question that's going to be worth for whatever other change I've got left in my. Ooh, I got another quarter. Is the label on this isocost curve still $200? Who said no first, nice and loudly? Okay, here, you get 25 cents. I don't know, because you're closest. So the answer is no, right? You're now producing 100 units of output. Okay, the price of capital stayed the same, but labor became cheaper. So it's now cheaper to produce 100 units than it was before. What that exact number is, if you really wanted to try and figure that out, you could actually kind of figure it out, right? So we know that this isocost is $200 right here. So what we've got here is $200 we're spending. If you're spending your $200 all on capital, you would get 15 units of capital, right? So the per unit price of capital is 200 divided by 15, a little bit north of $10, right? Now what you could do is you could figure out what, for that price of capital, 9 times that price of capital is, and you can read off the total cost of the new budget constraint here. Never going to make you do it, but if you wanted to figure it out, you could. The thing I want you to figure out is, if the price of capital stays the same, you're producing the same output, but wage becomes lower, then the label on this isocost line here has to be lower than $200. You're producing $100 units more cheaply than you did before. So that's all I'm going to say here. Isocost less than $200. So last concept here. Actually, no, this is a big one. Let me give you back your exams. So we're going to start with expansion of production next time. So before you start talking, you guys did really well, all right? I'm a stats nerd, so I produce pretty graphs that nobody understands. So let me tell you what you're seeing here. You could not talk for a minute because it'll save me 400 emails, okay? Number one, you did really well. I'm very happy, all right? So this was not necessarily an easier exam than previous years, and you guys did much better than previous classes. So, do this. You're good, all right? You shouldn't take this as, oh, this class is an easy thing, I can sail through it. People that do well on midterm 1 here always tank on midterm 2, so keep up the hard work. The mean out of 80 points, pay attention, was 67.8, which is in the 80s. Then you have the standard deviations here. You can sort of read off where you should start being worried, because there were 80 total points on the exam, and people can't make the transformation into a scale of 100. I drew you the same pretty graph, mapping this into 100, right? So A's are, go up to 90, B's to 80, C's to 70 for now, unless you start tanking. Then we're going to change that a little bit. If you're down here somewhere, you should worry, right? This wasn't a brutal exam, but you should be able to do better than that. So come see me. Regrades. Do not bother your GSIs. It's pointless, right? The only way you can get a regrade is if you appeal to me with a 1-page sheet in writing stapled to the front of your exam why you deserve extra points. Don't come to me in office hours and have me look for points in your exam. I won't, right? You have to tell me why we screwed up and why you deserve extra points. So I will post the answer key right after class, look at it, and within 1 week from right now, meaning the end of Tuesday's lecture, hand me your exam, I will take a look at it, and I will give you points back if we really did screw up, all right? If you want to come talk to me today, I'm in my office during my regular office hours, which is great. At the cozy office, there's still some chocolates left, so come hang out. Other than that, I think that's all I got to say. Questions before we hand this back? Yes? This is raw scores, right? I'm not curving anything until the final. All right. So what we're going to do is we're going to break up the class, so we don't have one stack here. Josh is going to stand right here. He's going to take last names A through E. And don't jump up now. Just give it a second until we've assigned everybody. Okay, so Josh here, light blue shirt, A through E. Sam is going to do F through I. And Sam's going to stand where you want to stand. Right back here in that corner. John is going to do J through M, as in morning. Right? And John, maybe you stand outside. Is probably the smartest thing to do. And I'm going to do the rest of them. Okay? So A through E,